All right, hey everyone. We're going to start our final topic in this class. So woohoo! Talking about multiple regression. And so this is really kind of like a nice way to finish off this class. First of all, because as we'll kind of see going through this, multiple regression, if everything from simple linear regression from the last section makes sense, you really should be in good shape for this section because it's really not that different from stuff that we've been doing. So that's really, really nice. And then secondly, we kind of worked with this GPA example when we first introduced modeling, when we had a model with no predictors and we kind of made a note that okay, well, like a model without any predictors might be useful in some situations, but in a lot of situations, we're going to have useful predictors and we're going to be interested in incorporating those into our model. And so in section 6, we were only letting there be one predictor in our model. The only thing we're extending here is that now we're allowing there to be more than one predictor. And so let's go ahead and jump in and just kind of see how this works. So I've kind of reproduced just the first 6 observations of this data set from the Educational Testing Service. So remember, these are just the first 6 students, but there's 1,000 total students in the data set. And what we're interested in is modeling their first year GPA from their students' high school GPA, their SAT math score called SATM, their SAT verbal score, and their sex or gender. And so we might be interested in this for a couple reasons. The first is that we might just want to know, for example, whether like SAT math score is associated with first year GPA after accounting for these other variables in the model. If there is strong evidence that SAT math is associated with first year GPA, even after accounting for those other variables, then we might feel kind of more confident that this SAT score is like actually like useful and it's actually doing something. A second goal might be that we're just interested in looking at a model to predict first year GPAs of new students. Predictions of GPAs could be useful to people who work at a college or university just to understand what to kind of expect from an incoming class. And so we'll kind of get into more about those specific goals in a second. But if you have the PDF, you could click on this link to an article that it's from 2019, I think, in the fall, and there was this lawsuit that claims or that's trying to get the SAT and ACT to be illegal in the UC or University of California schools admissions process. And so it's just kind of interesting to see where this SAT GPA example, how it actually shows up in like a real setting. And so the argument is that the tests are biased and that they don't actually really add anything more than a student's GPA. So we'll get into that in a bit. First, we're just going to introduce multiple regression. And so we did the same type of deal for simple linear regression, where we wrote this kind of true regression model. And so we're still going to have a response variable that we're going to call y. We're still going to have an intercept that we're going to call beta 0. And we're still going to have a slope and a first predictor, which we're going to call x1. The difference between what we did before and what we're doing now is that now we're allowing there to be many different predictor variables. And so I'm using these subscripts. I hope it's okay. This is the 1 is just to denote that this is the first predictor in our model. The 2 is to denote that that's the second predictor. and the k is just to denote that we have k total predictors. So k is just a number, not anything more complicated than that. K might be 10 if you had 10 predictors. In this example, k is 4 because we have 4 different predictors. Our fitted model is just we're going to throw a hat on our response to denote that it's being predicted, and then these little b1, b2, all the way up to bk are just coefficients that we're going to grab from a table of summary output. So nothing really more than that. Okay, so let's get into this example that'll probably make things make more sense anyway. Usually examples do. And so we've got some output that we fitted using some statistical software. Just like before, this column with estimate has these estimated coefficients that we need in the fitted model. And so just like we did before, let's kind of ignore this other stuff for now, ignore that, and just start with these estimates and writing out our fitted regression equation. Since gender is categorical, remember we need to define an indicator variable for sex. And so I'm going to define my indicator variable to be a 1 if the student is male, and a 0 if the student is female. So we didn't talk too much about like what group gets the 1 and what group gets the 0. I've just been writing them out so that it matches the output. The output you could see has this gender male. That's telling us that it's the male students that get the 1 from this line here. Okay, and so now that we have that indicator variable defined, let's grab the intercept, the coefficient for sex, coefficient for SAT math, and then keep going down the line for SAT verbal and for high school GPA, where our y hat is our predicted first year GPA. Okay, so far not too bad. Like it's super similar to what we did with simple linear regression, except now we've got more stuff because we have more predictors. Similarly to what we did before, we could find some predictions and find some residuals if we're interested in whether or not the model is like over predicting or under predicting for certain students. So let's go ahead and practice doing that. Let's find the residual for this first student in the data set. So remember, the residual is the actual observed response minus the response that's predicted from our model. And so if we want the residual for the first student in the data set, I'm going back to page 1. The first student in the data set is here. And so let's see. I'm going to combine that information with our fitted regression equation. So take our intercept minus 0.1418. I'm seeing that the student in this data set is male, and so that means I'm going to plug in a 1 for sex. I'm seeing that for SAT math, the student scored a 62. So that's really a 620, but we want to keep the same units as the units in our data set. So I'm putting a 62 there. And then I'm just going to do the same thing with SAT verbal, and then the same thing with high school GPA. If you calculate all that out, And if I calculated all that out right, you should wind up with a 2.89 points. And then to get his residual, I'm seeing that his actual observed first year GPA was 3.18. And so the residual is 3.18 minus 2.89, and that turns out to be 0.29 points. Blurg, I'm over the 10-minute mark. We're just going to keep going, though, because it would be kind of awkward to stop here. But you could do the same type of deal for the second student in the data set. And so this is really the same type of thing. I'm not going to flip back and forth like I did the last time, so you can kind of double check to make sure that you know where all these numbers are coming from. Throwing in a 0 because that second student in the data set is female. She scored a 64 on her math SAT. She scored a 58 on her verbal SAT, and then her high school GPA was a 4.0. Go her. So the model would predict that her first year GPA would be 3.27 points. Her actual GPA was 3.33. And so her residual is 0.06 points. And so we're just seeing from this that for both these students that the model is under-predicting. So the model under-predicts first year GPA for the first two students. So we obviously can't use our real data for this just because of kind of privacy concerns, but you might imagine it'd be interesting if we had our first year GPA data from the survey, or I guess that would just be GPA. It'd be interesting if you like found the predicted value based on the model and then compared that to your actual GPA and then just saw whether the model was over predicting or under predicting for what your GPA actually is. All right, and so we'll stop there. Again, I apologize, this is over my usual 10-minute mark, but usually introducing topics do take a little bit more time. So as always, let me know if you have any questions.